Hi, I'm Tom Henriksen from the DevOps Online Summit. Today, I'm joined by Scott Winkler, Terraform expert and author. Scott, introduce yourself to the people here at the DevOps Online Summit.
Yeah, so I am a DevOps engineer and a Terraform expert. So I've done a lot with Terraform. I've spoken at HashiTalks and HashiConf, written multiple providers, including the Shell provider, which has tens of thousands of downloads. I was selected as a HashiCorp ambassador and a core contributor in 2020. So, and then of course I'm the author of Terraform.
Sounds like you're a busy guy, Scott.
Yeah, I tell my wife that.
Yes. So to kind of get us started, Scott, what is Terraform, and kind of tell us what problem does it solve?
Yeah, so the way I think about Terraform, it's a deployment technology for anyone who wants to provision and manage their infrastructure as code. So the key principles of it are that it's declarative and that it's a provisioning tool as opposed to like a configuration management tool.
Excellent. Yeah, because it seems like in this space there's a lot of different tools. So, and we'll get into that a little bit more later. But to kind of tell us, what are the benefits and the use cases of Terraform?
Okay, so there's like six main benefits. The biggest one I would say is that it's easy to use because I think especially with the pace of technology changing so much that we need something that's easy to use and that works across multiple use cases. And that's what Terraform is. So not only is it easy to use, but it's cloud agnostic. So no matter what cloud provider you want to deploy to, or even the private cloud, you can use the same technologies. You only get to learn the technology once, but then whenever you want to deploy infrastructure, you can use the same skills in multiple places. Another thing is that it's declarative. And that's opposed to imperative. So what does that mean? Well, declarative is you say what you want and not necessarily how to get it. So imperative example would be like writing a for loop in Python or something like that, where you're explicitly telling the computer what it is that you want and how to do it. Whereas Terraform is declarative, which means that you don't necessarily state the reasons or the path for how to provision a server, for example. You just say, I want 5 servers, I want them to have this much RAM, this much storage, and I want them to be in this network. And then Terraform will go ahead and figure out how to get from where you are, your current state, to your desired state, which is having the infrastructure deployed and set up the way that you want. And there might be multiple different paths that it can take, but fundamentally, you really don't care. It's as long as you get the desired outcome, then that's good enough. And another thing is that it's a provisioning tool as opposed to a configuration management tool. So I think they're often confused, and I think that the technologies tend to do a lot of the same things. But it's actually the biggest distinguishing factor of Terraform as opposed to other languages. Because by provisioning, I mean, it can deploy the underlying infrastructure as opposed to configuration management, which would be things like Ansible, Puppet, SaltStack that are deploying applications primarily on the existing servers. And then the last thing is that Terraform is extremely expressive, even though it's a declarative programming language. So, I mean, you can think of like JSON and XML as declarative programming languages, but they're not very expressive. Whereas Terraform is expressive. It has many different functions that are built in that you can use. And if that's not enough, you have well over 100 providers that are on the registry that you can use, and different modules that people have published that you can use. So pretty much anything you would want to solve with Terraform, you could.
So at a high level, Scott, what would you say, how can kind of describe how Terraform would work?
So It's been interesting to watch Terraform evolve over the years because I guess I was one of the lucky people to start with Terraform when not really a lot of people even knew about it. And then I watched the features be added. And so back when it was very, very simple, like pre-version 1.0, um, you really saw what it was. It's a create, read, update, delete uh, lifecycle managers, specifically for APIs.
Hmm.
So imagine if I have a server and I want to deploy that server. Well, that could just be as simple as performing a create with the API and then doing a follow-up read to make sure that it's in the desired state. And that if it errors out, then I keep retrying it until it succeeds. And then if I want to destroy that, then I just perform a delete. Or if it's not in the desired state that I want, then perform an update. So everything is all about the create, read, update, delete lifecycle that we're all familiar with. But where Terraform adds its value is that it performs a lot of this routine logic that otherwise you would have to do yourself, like the error handling, if and the handling timeouts and knowing exactly which APIs to call because not all APIs are consistent, and then making this nice configuration language that you can use. So all of the heavy lifting has been done for you, and it's the code is written and it's part of these providers that you can use, like the AWS provider, for example, or the Google provider, or the Azure provider. You can use these providers, and then you can declare your configuration as code. But what that makes it really interesting, though, is that Terraform is called an infrastructure as code technology, but it's actually in everything as code technology, because anything that you could express as a declarative format, you could do with Terraform. For example, like I've written a Minecraft provider that can provision a castle in Minecraft. And I've seen other people that have created a Domino's provider that will set up their, how often they want their pizza to be delivered, for example. Anything that can be controlled with APIs, or even if you want to go like a local provider, because there's the distinction between local providers, which are providers that only impact things on your local machine, versus remote providers that could be doing things remotely. So the Terraform providers are just wrappers around this process, and it could be anything. It could be any kind of process, but as long as it follows create, read, update, delete, and it has some concept of state, then you can manage it with Terraform.
Interesting. So you mentioned this a little bit before, Scott, but kind of talk to us about how Terraform compares to things like Ansible, CloudFormation, and some of the other IAC technologies.
Yeah. So Terraform was inspired by CloudFormation. I've actually spoken with Armand, the founder of HashiCorp, and he said that that's where they got the idea for Terraform, was from CloudFormation. So CloudFormation, if you're not familiar with that technology, it's probably the first real good attempt at declarative infrastructure as code. And it uses JSON, and it's for AWS exclusively. So you can't use it for deploying to any other kind of cloud like you can with AWS. And it's not as expressive because they don't really let you extend it as much. And then, of course, you're writing it in JSON. So despite all the flaws, the initial idea is really good, where you declare what you want in some kind of format, and then you can just deploy that as a stack, for example. And if you don't want that anymore, then you could roll back that stack. So Terraform is very similar to CloudFormation, and also is very similar to the other kinds of analogous technologies to CloudFormation. Like Azure has their ARM templates, and Google has their resource manager, I think it is. And they're all very similar, except again, they're proprietary to that cloud, so they don't work for other kinds of clouds. They lock you into that vendor, and then they're not as easy to use because they haven't built the community that Terraform has.
Yeah.
Terraform is actually most similar to Pulumi, actually, and this is a technology that was gaining some traction maybe about a year ago. I don't know where they're at right now, but it's actually the most similar to Pulumi. The only difference between Terraform and Pulumi is that Pulumi is not declarative. So they rejected the notion that declarative is inherently better, and maybe they have some merit to that. But you write your configuration in Python or JavaScript or Java or something like that.
Yeah.
And I actually don't really like it because, I mean, I guess I'm biased, but it just feels like if you write the templates like that, it just ends up being like the same thing anyways, just messier. And then you have, of course, Ansible, SaltStack, Puppet, all of these older players in the deployment field. And again, these are really solving a different kind of problem because Terraform is all about deploying the infrastructure. So it's if you have a clean slate, you have an empty data center or an empty cloud, and you want to deploy your infrastructure, Terraform is what you use for that. That makes it a provisioning tool. Ansible, even though it's declarative in the same way that Terraform is declarative, and even though it can do some infrastructure provisioning, it's really best at managing applications. So when you already have the servers running and you want to do a blue-green deployment, for example, of your application stack, you can do that. And in fact, Terraform and Ansible work pretty well together. And Terraform and any other configuration management language would also work pretty well together because you use Terraform to set up your infrastructure. You use something else, configuration management or CI/CD process or whatever you like to deploy and manage the application after the infrastructure is deployed. And you can use Terraform for application delivery. In fact, I have an entire chapter on that in my book. But I think that's just kind of using Terraform in a way that it wasn't really intended to be used, kind of like a golden hammer. I mean, just because you can doesn't mean you should.
Yeah.
It does work well. Terraform works really well, actually, for serverless deployment, because in that case, you may actually want to package your application and deploy it as like a microservice, for example. Just deploy your Lambda function, deploy your API gateway, deploy the code that goes on that, and then not worry about it or think twice about it. Terraform works really well in that case. So I guess it really depends on the situation that you're using Terraform and some of these other technologies for when you might choose one over the other. But definitely, I think Terraform right now is the winner, and when it comes to infrastructure provisioning for the cloud, the private data centers or public data centers, or if you're trying to migrate from the private cloud to the public cloud, that's where Terraform really excels.
Now, you mentioned it earlier, Scott, and you have written a book. So tell us a little bit about how we can learn more about Terraform.
Yeah. So I do have a book right here. It finally was published 2 years
Awesome.
in the making. So what I really like about this book is that I had not just myself, but I had many reviewers and people that were commenting on it and reading through it to give me their feedback. And I also spoke with a lot of the engineers over at HashiCorp too to get their feedback on what would be good to put in a book. And I think this book really encapsulates all of the best practices of Terraform and also practical use cases of Terraform. There's lots of introductory guides to Terraform. In fact, there's so many of them that, I mean, you watch some YouTube videos. So then the question is, like, why is there a need for a book? And this is actually almost a 400-page book. And it's because learning Terraform is very easy, but then when you get to you naturally get to the next question, like, well, what do I do next? Like, what kind of problems can I solve when it comes to, for example, CI/CD or serverless, or deploying clusters, or managing application delivery or updates, or complicated things that can go wrong with Terraform? How do you do that? Or how do you write a provider? And so that's what this book answers. It doesn't shy away from the hard questions, and it really gives you a very solid look at the entire Terraform ecosystem, and some of the history too, like, well, why did we end up where we're at now, and maybe what can we expect in the future, and what are the limits of Terraform, and so it really just explores some of that.
Awesome. That's a lot of good stuff there, Scott. So you've shared a lot with us, Scott. We appreciate it. Any closing thoughts?
I think that Terraform is a great technology, but it's just one tool in the tool belt. So again, just a word of caution that people try to make the latest technology seem like it can do everything. And I think that Terraform is really excellent at what it does, but just keep in mind that there are many other technologies out there that are equally good, and it's a process to learn technology. Even something as simple as Terraform can be deceptively complicated. And also, you can save 50% off my book with the code TS Terraform. So that's TS Terraform. Yeah. So
we will have that in the show notes.
I recommend getting the paperback. It's really quite nice.
So to use that code, just to confirm with you, Scott, that's got to be on Manning, right? The publisher.
Yeah, the Manning.
Okay.
So the book is also on Amazon, but there's no discount code for Amazon.
Sure.
Yeah. So
I'll make sure we'll have that in the show notes so people know where to go and that code so they can use it. So, Scott, thanks so much for coming on.
Thank you.
Don't forget to subscribe to our YouTube channel. On behalf of Scott Winkler, I am Tom Hendrickson for the DevOps Online Summit.